Recording in progress.
Okay, let's go over the homework first. So a few things we're doing today. We'll go over the homework, see if there are any questions. I did make a homework quiz. It's ready, finally. It's a good one too. Now we'll be near the end of class. We do have more notes to cover. Just so you know, guys, please, the notes will start over here on page, well, I gotta go to the right page. I think 27 or 26. No, I was right. So notes are going to start here today on page 27. We're going to go up to page 30 today. So we'll do that. So we'll get 4 pages of notes done. After that, we'll do the homework quiz. The homework, I'm actually going to reduce quite a bit. It'll be called homework number 11. And I'm not going to sign all of these problems. Perhaps I'm actually going to sign up half of it. So you might be able to get some of the homework done today in class if you have time. And then these last 3 problems are part of the following homework. On Wednesday, we're actually going to finish off the unit. So we will finish the unit on Wednesday. We'll do the rest of the notes, have another homework quiz, go over homework, all that stuff. On Friday, I'll have the study guide ready for you guys. Our test is Wednesday next week, which is the 27th? Yeah, it'll be 27th. So we'll have 2 full days of review. We'll have a review day on Friday, a review day on Monday when we're back, and then Wednesday. And thankfully, we're finally back to a normal schedule for at least 3 weeks until things go upside down again. So yeah, the schedule's been crazy. All right, okay. So let's talk about homework. Any questions on the homework you guys want to ask about? 52, 53, 54A, 55 to 60, all 87. The homework is posted. The solutions are posted at School Gen homework number 10. So it is there. There's one homework from previous, I think homework 8, I still need to post. I'll do an audit and get things all figured out by tomorrow. Oliver, good.
Clarification question for 87.
Yes, please.
So to find the amplitude, obviously you just look at
the stretch.
To find the period or the B value, you would take the period, put it over under 2 pi.
Yes.
But for the vertical stretch, the vertical shift is also pretty self-explanatory. But for the phase shift, would you go from the point where x is 0, like the asymptote for the cotangent? You have one of your equations is like
so
pi over 6.
As a tangent, you go from 0 for sure, because the middle of the tangent graph is at 0, right? For a cotangent, the parent function is at pi over 2. So you go from pi over 2 for a cotangent.
So when I did my function and I just had 3 over 4x, no phase shift because the point is that pi over 2 was wrong. I had to do
for cotangent.
I had to do plus pi over 6 for cotangent.
You have to do about that.
Yeah, so I think you go by when the point of x is 0. I'm just making sure that you don't have anything different.
Oh, you know what? No, you are correct. For cotangent, for cotangent, you start with the vertical asymptote that's on the y-axis.
Yeah.
You go based by, because then everything gets shifted, or sorry, everything gets compressed or expanded depending on what the
that's not affected by the compressor expanded.
But by the period change, right? Exactly.
Okay.
Yeah, actually, since we're on it, let's talk about it. Let's do 87. Since we're on it. Okay, so tangent looks like this, guys. Right? Okay, that's crappy. I can do better. A little better. Okay. So here's a parent function for tangent. Y equals tangent x, right? Now it's pretty clear it's reflected, right? So definitely A is going to be negative. And also it's stretched by a factor of 2, it looks like. So A is going to be negative 2. The middle's at 0. Now it's at pi over 2. So your H is going to be pi over 2. Your K is going to be negative 1. The period is 2 pi. No, I lied. The period is 4 pi over 3. Is that right? Yeah. 4 pi over 3. Set that equal to 2 pi over b. If you solve for b correctly, you oh, you're right. Sorry. My apologies. It should be 3/4, right? You get 3/4 for b. Okay. So the equation for the tangent would be y equals negative 2 times tangent bracket 3/4 x minus pi over 2 bracket minus 1. Now, if you want to verify, here's what we do. And actually, this might be kind of good because do you guys know how to adjust the axes on Desmos? I'll show you. It's really simple. So y equals negative 2 times tan. I'll put 0.75. Same thing. X minus 0.5 pi. Just type pi for pi. Minus 1. Okay, let me go ahead and clear screen for a sec. All right, so here's what we do. You go to the little wrench here, and you go to the x-axis. And let's say I want to go from, it's really up to you. Let's say I go negative pi to 2 pi. But here's the big one, the step. Let's say I want this every pi over 4 units. There you go. So it could do the adjustment for you. Or let's say I do every pi over 6 units. It could do that for you too. So now let's look at the graph again, which is right here. Okay, so I'm gonna have to toggle back and forth. So it looks like pi over 2 comma negative 1. Boom, there you go, pi over 2 comma negative 1, that works. Looks like you have a point at pi over 6 comma 1. There you go. Because pi over 6 is roughly 0.5, because pi is 3.14, right? Divided by 6, about 0.5 something. We have 0.5 pi over 6 negative 3. So 5 pi over 6, that's like 15 over 6, like 2.5-ish. So 5 pi over 6, yep, negative 3. So that's how you can verify your work to make sure you're getting these right. So you can feel comfortable that you've got it correct. Or if you have to play around a little bit, you could. But that's how that one's done. Then as a cotangent, so cotangent looks like this, right? Is the asymptote on the y-axis, asymptote at x equals pi. Graph looks like this, right? So again, A is still the same. It's now you're gonna say A is 2 now because it doesn't reflect. So A is 2, not negative 2. The B value is the same, still 3/4. The K value is still the same, negative 1. It's H that changes, right? Now the asymptote was at 0. Now it moved to negative pi over 6. So you can say H is pi over 6. Sorry, negative pi over 6, my bad. Negative pi over 6. So you have y equals 2 times cotangent, bracket, 3/4, x plus pi over 6, doing x minus h, and of course, minus 1. Now, let's punch it in. We go to Desmos, change that to cotan, and plus pi over 6. Okay. Clear. So, oh, sorry, did I make a mistake? Oh, duh. Yeah, I was like, wait, that doesn't make it. There we go. Whew. It's getting a little nervous there. All right, so yeah, kind of hard to tell, but let me go back to the graph again. So pi over 2 comma negative 1. Let's take a look. Pi over 2. Yep, there we go. Pi over 2 negative 1. Got it. 5 pi over 6 negative 3. We know that was true. Pi over 6 1. We know that's true. Kind of zoom out a tad. I mean, it's hard to tell, but yeah, it looks like it gets really close to negative pi over 6. Yeah, it gets infinitely close, but it's never going to break it, right? It's never going to break that boundary. Pi over 6 is right over here. Yeah, so this is the beauty about Desmos, that you can do this very easily, right? Very fluid. So yeah, there we go. And thank you for Oliver for mentioning that.
You have to move it from when x equals 0.
Here's the reason why I don't.
Yeah, and that's what I thought was true, but things that the middle of the graph, because really where does the cycle start? The cycle really starts at the down. Right? So the cycle starts there. So what's happening is that it has an x equals 0. So whenever you have a parent function, always have the starting point at 0. Right? Like tangent, as far as the origin, it says that's the middle of the graph. Okay? But for cotangent, it's already on the first vertical asymptote. And then I realized, oh, now the vertical asymptote is negative 5 or 6. That's why I made it negative 5 or 6. Now the middle of the graph is adjusted by the beta. If you stretch it, right, the last asymptote changes as well as the middle changes. So the middle is heavily looking like not so much by h. For cotangent, but for tangent, shift based on the origin or the middle of the graph.
Okay. So that was good. I'm glad we did that. That was a very good discussion because we needed to have that talk. Okay, that was the last problem. Anything before 87 that you guys want to ask about before we move on? Anything before? All the answers are here. Just you know, today's homework quiz is not like 87. Don't worry. Today's homework quiz is going to be on something like 52, kind of. Yeah, basically 52. Or like 53, something like 53. And then also something like 54A. Actually, I'll tell you right now, it's almost identical to 54A. I just changed something. Anyone want to ask about this? Okay.
Well, that's kind of hard. You want to talk about an inverse sine? We don't need to make it on that. Oh, I was just talking about it.
So guys, remember inverse sine of x. So you can actually make a little table if you want. So remember the inputs are actually the coordinates on the unit circle, the output's the angles, right? And what's the default range here from negative pi over 2 to pi over 2? That's your default range. So let's say this is negative pi over 2 here. Let's say this is pi over 2 here. So what's the inverse sine of 1, right, gets you pi over 2. I know this. Inverse sine of negative 1 gets you negative pi over 2. And of course you get that. So that's the parent function. Okay, and then of course you stretch it or you shift it. So that's not hard, right? I think you guys will be fine with that. So. Of course, things get a little dicey with the other ones, but we're going to talk about that today. Because I know I didn't talk about inverse secant or cosecant. I'm going to talk about that today with you guys. So, okay, we're okay? All right, so make sure you submit the homework and let's move on to the notes. So get the notes out. I'm going to start with page 27. We're going to talk about the graph of inverse cosecant. We're going to talk about graph of inverse secant, inverse cotangent, do some more practice problems. All right. Here we go. Okay. So remember, if you graph cosecant, right? Guys, quiet, please. If you graph cosecant, you start with sine, right? Start with sine. Sine looks like this. We know this now, right? That's y equals sine x. You don't have to write this down, just do this for a reference. And of course, you do these little like they kind of look like parabolas. They're not really parabolas, but they look like them, right? And then you put asymptotes where it touches where the sine curve touches the x-axis. And I'll erase the red because it's kind of distracting. So there's your cosecant graph, right? So that's a cosecant graph. And now the one that you see off to the lower left of my screen is the same thing. It's just they show it from negative pi over 2 to pi over 2. So that's at negative pi over 2 and pi over 2. So they're only showing a portion of it, right? Now, why do we restrict the domain?
So, like, for example, right now, this is past horizontal line test. Right? It fails at the same time, right? In order to make it work, we really have to focus on a portion of the cosecant graph that would pass horizontal line test. This would pass this portion. And where's the portion going from? Negative pi over 2 to pi over 2. Same thing like inverse sine, right? Same thing. We use the same domain. But why is 0 not included? Because 0 part of the domain here. Because sine 0 is 0, but then cosecant can be under 9, right? So 0 has to be explicit in the domain. The range, just look at it. Like, it's pretty obvious. It goes down 1 and up, then 1 down. So just look at it. That's the range.
All right, so that's what we have there for cosecant. So let's do the inverse cosecant graph. This is where it gets mind-bending a little bit. So what I'm going to do is make a table for cosecant. It's always a good idea to make a table whenever you're doing something for the first time. So there's clearly a point at pi over 2, comma 1, right? And where else is there a point that we can identify? Negative pi over 2, negative 1, totally, yeah. Mm-hmm. And while we're at it, let's look at it over here. Pi over 4 root 2. Again, it's always a bit mind-bending. What's the sine of pi over 4?
Root 2 root 2, or 1 over root 2. So cosecant of pi over 4 is flipped. So it's root 2, or 2 over root 2, which is root 2.
And you have another point right here. So now for the inverse, what do you do with those two columns? You flip them, right? So this is for inverse cosecant x. You got to flip them. So now it'll be 1, negative 1, root 2. But the problem is that I'm not going to do I'm not going to do negative root 2 or root 2 because that's going to be outside. So actually, I'm not going to do that. So let me get rid of those. We'll just do 1 and negative 1. You'll see why. Okay. So remember, when you have an inverse, the domain and range also switch. So what's going to be the domain for inverse cosecant? Yeah, right. Everything switches. From 1 to infinity. And then likewise for the range, which would have been the domain for cosecant. Okay, so we're starting at 1, and we have negative 1. And there's a point 1 comma pi over 2, which is right here. Then 1 negative pi over 2 right there. So that's pi over 2. That's negative pi over 2. So how will the curve look? Well, what's a vertical asymptote here? X equals 0, right? So would it be a vertical asymptote or horizontal asymptote for this one? Yeah, it'd be a horizontal asymptote. It would look like this. And
I was a little immature in time or negative power because these outputs will not fit by default domain for the inverse cosine. So that was kind of crazy that I did that because it wouldn't have fit anyway. Oh, actually it does. Wait, then what am I doing wrong then? Oh, it does.
You thought 5 or 2.
Oh, you know what? I was gonna do this up. Yeah, let's do it. Why not?
sorry. Yes, that would work. I'm losing my mind here. That would work. Root 2 and pi over 4. So I just got things backwards. See, I told you, it's a bit mind-bending. My bad. Yeah, those would work. Yeah, so I mean, it's going to be surprised somewhere over here and probably somewhere over here. So that would be root 2 comma pi over 4. I'm just kind of guesstimating, right? Yeah, totally work. Why would I say it's when that's crazy? Yeah, okay. So we're okay with that? How inverse cosecant works? Okay. Let me go and clear the screen. And just to summarize, and then we'll do some practice problems. So the unique angle y in the interval from negative pi over 2, comma 0, parentheses, mind you, union 0, pi over 2, bracket, is denoted by y equals inverse cosecant of x. Or we could write like this, arc cosecant of x. So you can write like this, arc cosecant. And the domain again, negative infinity to negative 1. Union, bracket, 1 to infinity. The range is going to be negative pi over 2, comma 0, union 0, comma pi over 2. Okay, we're okay with that? Okay. Let's work these problems out. Now, here's the thought process I want to go through, because inverse cosecant is a little strange. Each of these equals an angle, right? Each of these equals an angle. And when you ask to determine the exact values, you can give the answer in degrees or radians. I don't care. I'll leave it up to you. Yeah, go ahead. No, so I don't care.
So you would never like have us receive.
No, I'll let you yes, for the rest no. Okay, I'm just kidding. No, I don't care. I honestly don't care. I mean, we are going to do more radiant, like graphing for sure, and solving. Like, okay, for solving an equation, I probably would do radiant because that's going to be easier. And also just have to get used to this. Let's do calculus. That's all. I mean, probably everybody's used to calculus. But for something like this, I don't care. Yeah. Yeah, I don't, for this, I don't care. Okay. So cosecant theta equals negative. Okay. So here's the most important part of this problem.
Think of this as cosecant theta. So this equals an angle. Think of this cosecant theta. Don't flip this, because you're gonna mess things like flip. Technically, we are flipping the inside. I'll explain why in a second. But think of this as cosecant theta. That's where it came from, right? Where the come from came from that. So now,
what's the next most logical step? Sine theta equals what? Negative 1/2, because that's flipped, right? So now theta equals the inverse sine of what? Negative 1/2. And now you can use your unit circle to figure that out. That's in the fourth quadrant. Negative half is going to be at negative 30 degrees. Or negative pi/6. It's a little bit more painstaking to do it this way, but I will say that this is more of a guarantee of getting the question right if you think about it in this manner.
now, once you get really good at it, really just flip this guy over. Do the inverse side. That's all I do. You flip this inside over because it's an inverse, right? You don't flip the outside, you flip the inside, right? It's all inverted. So here, just to save the time,
I'm not going to do it. I'm not going to do B in the same drawn out way I did part A. I'm going to show you the quick and dirty way, but you should understand the drawn out way so you can make sense of it. So here's what I'm going to say. I'm going to say inverse sine, and what will be my input now? Or 1/√2, exactly. And where does that happen? Yeah. So that's what you got to do. Okay. And the next one's a composite function. So let's work out secant 2π/3 first. Let's get that out of the way. Actually, switch colors for a bit of contrast. Let's go for screen. Okay, secant of 2π/3. 2π/3 is in the second quadrant. Secant there is negative half, so that's -2. Right? Am I correct? Oh, no, I'm wrong. Wait. Oh, wait, is your notes different than mine? Hold on. My notes are, hold on, let's see.
oh, no, we're the same. We're good. Yeah.
Right. Yeah. Okay, I got it. How did I do what? Oh, so
Sine of cosine 2π/3 is negative half. Right,
Yeah.
cosine, and then the secant, right? So you got flip.
so then you're doing inverse sine of negative 1/2. So what angle is that, guys? It's the fourth quadrant. What angle would that be? Negative 30 degrees or negative pi/6, exactly. Yeah.
So again, you gotta know your unit circle really well. You gotta do that part first, that's your second picture. And then you gotta do inverse cosecant -2, which is inverse sine negative half, which happens at negative 30 or negative pi/6. Okay.
Let's keep on trucking here. Let's do inverse secant, guys, and then inverse cotan, and we'll wrap up these notes. Okay. All right, here we go, guys. Let's do this again. All right. I'm gonna go a little faster here. Now you guys get the idea what's happening. So cosecant looks like this, right? Generally speaking, cosine is this, right? You know this. You draw the little U shapes. Little U shapes like that, or parabola shapes, whatever you want to call them. Asymptotes. Should be more straight. Erase the red. Right? So yes, this looks like a portion of it. And why did we
Want to take a portion of one past horizontal line test, right? This fails horizontal line test, it gives a zillion places, right? So we want to restrict it, and just like inverse cosine, we restrict it to 0 to pi. But don't include pi/2, because pi/2 is undefined for secant, because cosine of pi/2 is 0, so secant would be undefined. So we have to exclude exclude pi/2 from the domain of secant.
So then when I do the inverse secant, right? When I do the inverse secant graph, my domain and range are going to switch from the original. So now I'm going to go from negative infinity to -1, just like before. 1 to infinity, just like before. Negative infinity, -1. Sorry, oops, sorry. I meant to say 0. Sorry, bracket 0, pi over 2, parentheses, union, parentheses, pi over 2, comma pi, right? Boom, boom, boom. And I don't really feel like making a table. You're just going to switch those coordinates. So you have a point at, actually, what the heck? I'll make a table. Yeah, I'll do one. So you have a point at 0, 1, and a point at pi -1. What else? I got a point at, can't read that, pi over 4, √2, negative pi over 4, still √2 because it isn't even, sorry, 5 pi over 4, my bad. 5 pi over 4, negative √2. Okay, and then everything switches, right? 1, -1, 0, pi, √2, negative √2.
Isn't 5 pi over 4 out of the 3?
Not for cosine.
Oh, anyways.
Yeah, same thing.
So is it sort of pi?
5 pi 4, 3 pi 4. You're right.
Thanks. Sorry. Yes, you're correct. My bad. My apologies. So 3 pi 4. Good catch. Plot the points. So anyway, that's going to look, it's going to be a little more elevated compared to the secant. So we have so I'll be a pi. What was it pi for?
Yeah. Oh, so when you do the secant pi 4, first of all, the cosine pi 4 is root 2. So the secant got flipped over.
Yeah.
So that's why it's root 2.
Oh, I thought that point was like on the y-axis.
No. And then of course you have 1 and 1, -1. So you plot the points. We have 1, 0, -1 pi. Now here you have a vertical asymptote here. You have a horizontal asymptote at y equals, guys, stop that please. Thanks. All right, y equals pi over 2. And the graph looks like this. There you go. Graph looks like that. Okay, we're okay with that? We good? All right. And again, just to fill this out really quickly. Goes from 0, pi over 2, union, and it's y equals inverse secant of x, or y equals arc secant of x. Domain again, negative -1, 1 to infinity, and of course 0, pi over 2. Pi over 2 is excluded for obvious reasons because it's undefined there. Okay. Now here you have to find inverse secant of -1. So really it's like saying this equals theta. So secant theta equals -1. So guess what? Cosine theta also equals -1. When you flip it, where's cosine -1 on the unit circle? Pi. Boom. Got it. Theta equals pi. Very nice. This one, now you get really good with it. You can say cosecant. And I'm going to say inverse cosine of what on the inside now? What's going to be on the inside there? Yeah, -1 over √2. Now, where will that happen on the unit circle? For the default range for inverse cosine. Yes, second quadrant, 3 pi over 4. Cosecant of 3 pi over 4, which is going to be 1 over √2 over 2, sorry, negative. You are correct. Yes. Okay, you guys staying sharp. Or just root 2. Right. And by the way, for part A, you could set 180 degrees also. That would have been fine. Okay, so far we're okay. All right, let's keep moving. Okay, example 3. So remember this right here. Oh, I love this problem. I love this problem. This is definitely a test problem, guys. Yeah, I like this problem. Okay.
The reason I like it, it forces you to do one more out. Here, that's an angle, right? Any inverse trig function is always an angle. That equals some theta, right? So here's what I'm gonna do.
I'm going to say secant theta equals 1 over t, right? Because that's true. If theta equals inverse secant, the secant equals 1 over t. Or cosine theta equals what? T over 1. Exactly. Draw. And by the way, t is bigger than 0, so we're going to be in the first quadrant. So let me draw a coordinate plane. We're going to be in the first quadrant. So that's t, and that's 1. Let's say I call this y. How would I solve for y in terms of t, guys?
So T is greater than 0.
Yeah, it's going to be a Pythagorean theorem. So y is root 1 minus t squared. So I'm going to erase this and make this root 1 minus t squared. Yeah, totally. I like this problem a lot. So now, your theta is right here. What does the question want? It wants sine theta, obviously. Well, that's easy. That's just root. Or just root. And there you go. That's your answer. And we're in the first quadrant, so I'm not to do plus or minus, right? Don't have to worry about that. You know, minus, when it's not y by itself here. Because we got what now? What if this were pointing down, by the way? What if I was in the fourth quadrant? Then what would you do on the radical here? Be negative, exactly. Ooh, I might be on the test like that. So that'd be negative. Yeah. It was pointing up, it was pointing up. So there we go. Excellent problem. Okay, questions before we move forward? Now, it's a lot of material at the end of the day I'm throwing your way. I know, sorry. We'll pump the brakes after Wednesday. Okay, finally, inverse cotangent. All right. So cotangent's right here, right? So y equals inverse cotangent of x. Domain range switch, right? So now we go from negative infinity to infinity for my domain. My range goes from 0 to pi, not included. If I do a table here, I know there's a point at pi over 4, comma 1, pi over 2, comma 0, 3 pi over 4, comma negative 1. Swap x and y columns, 1, 0, and negative 1, pi over 4, pi over 2, and 3 pi over 4. So here's 1 and negative 1. Here's 0. And I'm going to go 1, 2, 3, 4. So this will be pi and pi over 2. Now the asymptotes, you have two asymptotes, one at x equals 0, one at x equals pi. Now they're going to be y equals those numbers, right? Y equals pi and y equals 0. And if I plot the points, let's go pink, 1 comma pi over 4. Let's do a better contrast. Go brown. Here, here, here. So it looks like that. That's inverse cotangent. Question how that's created? So again, the domain is from 0 to pi. It's denoted by y equals inverse cotan of x, or y equals arc cotan. That's just another way of writing arc cotan of x. Again, domain is all real numbers. Range is from 0 to pi. Yeah, maybe. Yeah. Okay. Well, let's look at the homework. Well, let's look at the homework. Hold on, let's look at the homework. Let's see. I don't know. Yeah, you guys could. Yeah, you guys could handle one of them. It's not actually. Okay,
I'll tell you right now, I'm not gonna do a transformation of inverse.
okay. I won't do it. That's fine. Because that's too much. There's too much material. I won't do it. I won't do it. But I could do inverse sine, inverse cosine, inverse tan. Okay. All right. All right. Okay, guys, let's finish strong here. Let's finish these up. All right. So we got. So here's what we'll do. Let me do example 4 here. Then I'll have you guys try examples. Let me clear the screen. Hold on. So let me do these with you guys. I'll have you guys try page 30 in your groups, and then we'll do the homework quiz after that. We're finishing. We're doing example 4 right now. Yeah, example 4. Page 1. Yeah. Okay, guys, quiet, please. Let's go through these. Okay, inverse sine of what, guys? What's that going to be on the inside? 2 times what? Good. So inverse sine of 1, which is what? 5/2. And just for simplicity's sake, we'll just keep all in radians for now. But yeah. Okay, that's cosine of inverse sine of -½ That's -30 degrees. So that's going to be √3/2, yeah. Tangent. What's that one? That's going to be cosine inverse of -√3/2. That's in the second quadrant. That's going to be 150. Tangent 150, that's y for x. Okay, let me back up a little bit.
You guys need help understanding, Steve? Okay, tangent is always one that, especially at 30 or 6, always kind of a little bit. Because you know tangent y for x, right? We're going to 150. I think that makes sense. We have an inverse secant to negative, this is an inverse cosine of -√2. That clearly is going to happen as an exponent. The exponent -√2 at 150 for cosine. Now you tangent that is y for x. The y coordinate there is half. The exponent is -√2. So if I do y for x, you get -1/3 or -√3.
That's a mindset you want to have for that one. Remember, this one equals an angle. Did I make a mistake, Arya? Okay, good. All right. Okay. Hey guys, let's finish strong here. -5. Does that make sense? Fourth quadrant, right? So you're doing tangent of that angle. So tangent theta, which is what, guys? -5/12. Okay, we're good there. And lastly, cosine pi is -1. So it's inverse tan of -1. Where does that happen, guys? -π/4. -π/4.
If your tangents are five.
I was right.
Ooh, you're right. You're right. You're right. You're right. You're right. It's 354. Correct. You are correct. That's correct.
That's probably fine. We find 0, 5. Yeah, it is. Yeah, it's just the way it is. Yeah. It's yeah, it's because we chose the middle of the graph. That's why.
Is it? Oh, I thought that was a 5. Never mind.
Cosine pi. Well, cosine pi is -1. Inverse cotangent -1, which is same as inverse tan -1, which happens in the second or fourth quadrants. But we're gonna go to the second quadrant as part of our default range.
That's a range of 0 to 5.
But inverse cotangent is different because look back at our notes again. Because remember, our graph was this, right? So went from 0 to 5. Charlie, go ahead. Guys, quiet, please. Go ahead. I know, great question. That's because of the way we did the graph. Because of this right here. That's why. Well. So technically speaking, you okay. This is a great discussion. Actually, I am definitely in agreement with what a lot of you guys are saying here. Because what if we did our cotangent like this, right? How can we kind of done that instead? The problem is that because that would pass the horizontal line test, but I'm not sure what I would do about the pi over 2 negative pi over 2 part. I think that's where I would get. Actually, no, that could work. What could it? I don't know. Actually, you know what? No, I got it. That's not 1 to 1 because that's gonna have
Zeros.
yeah, 2 zeros. That's what we get this. That's what we get this. Yeah.
So what do you do?
Yeah, because tangent would have that problem. So, okay, guys, let's okay, last thing, guys, let's work on these really quickly. See how you guys do. I'm gonna do it too. I'll turn off my screen. We'll see if we get the same answer, and then we'll do the homework quiz. You're gonna evaluate them. So you're gonna give an answer in terms of X. Each of these will have an answer in terms of X. You're gonna draw triangles, Audie. You're gonna draw triangles in the coordinates. The coordinate plane.
I'm sure again. Or you better leave it. Yo, what are you No, but that's how we already.
I'm doing it, guys.
So let's just take sound of no, but this is tangent, right? So the tangent of this angle is X. It's sine of the cosine. Yeah, tan that, right? So what is the hypotenuse?
Okay, I got all done. You guys, let me know if it's next.
Yes, it is.
Wait, but other than that, I was right. No, I was right other than the root. I forgot.
Oh,
What do you mean? It's not. Yeah, I forgot the root. Mr. E, shouldn't it be in the quadrant one? Because it's a positive 2x?
No, stop.
Why?
That's, you can get me all, I got you this time.
I don't understand what I'm looking at. Like, I don't understand what it's like.
Okay, questions at all? Before we start the homework quiz?
I can help.
Yeah.
Okay, I'm gonna stop my recording.
So,
Let me freeze the screen.
no, tangent of theta equals x, right? So tangent.
No, actually.
Tangent of this angle is x, right? So what is sine of?